Hello everyone, welcome to realityPaint. I'm really excited about this new update. We just released an update called version 1.0.3 and it has what you might think is being a small new feature added, but I think it's an extremely important feature and I'm going to show you why. Okay, and so as we can see here, we've implemented a per pixel hidden surface removal. That's a bit of a mouthful, but let me show you what that means. What that means is that if we have a model like this, that we can detect the hidden surfaces, like the areas behind the ear here, for example, or on the other side of this nose, or whatever the case is, or the inner geometry that's in the mouth when you're painting here. All that hidden stuff we can now detect on a per pixel basis instead of a per vertex basis. Now, so let me show you what that means. Up until now, per vertex was the method you would typically use to not paint on that hidden stuff. And per polygon is the same thing as per vertex, except for it's more a little more it's less generous. But anyway, that's not important right now. Let me show you what the per vertex is. Now let's zoom in on this ear, because this is a really good example, and show you the wireframe. Now what it does is that each one of these little vertices, it'll basically detect to say, is this hidden by something or not, right? Like if you can see there's a polygon here, there's a hidden part of it, it's hidden behind this here. And the vertices that are hidden will be faded to 0, while these ones to 1. So if you paint, it'll, let me show you, actually, instead of explaining, let's get rid of the wireframe and just paint. Here we go, all right? And if we notice that this part is fully black and it fades over here, right? And it fades to all those vertices that are hidden are faded out, such that if you look behind, right, all the vertices that were completely hidden have no paint applied to them, while the vertices that were all visible had all the paint applied, and the ones that had half and half were kind of faded, all right? And you kind of get this little bit of a jaggedy pattern, right? And so that's the way it has kind of worked up until now. And if, well, you can always that versus painting straight through it, of course. You can just say none and just paint straight through it, but you get the paint on the, let's show you, on the other side of the model too. So that's not desirable in many circumstances, okay? So this big problem of how to not paint on hidden surfaces, that's how we dealt with it before. And it generally, in this case, it works pretty well for objects like this that are sort of uniformly distributed, where you have a lot of quads or triangles that are roughly the same shape and well distributed all around, and it works quite, quite well, but not perfect in some situations, and I'm about to show you one of those situations right now. So here is, I'm going to load in a new project now. Before I do that, sorry, I'm getting ahead of myself. I didn't show you what the per pixel thing does. Okay, here is the per pixel. This is the new feature, okay? And so what this does is, it also has a precision value. I'll get to that in a moment. This does is says on a per pixel basis, I'm going to determine whether they are visible or not. And it uses the depth buffer, which is like your viewport here with the colored pixels, except for instead of color, you have depth values, right? And so it's using the differences in those depth values to determine whether something's visible or not. So let us show you here now, painting the same ear with a per pixel hidden surface removal. Now you just notice a little bit around these edges have been culled, right? But everything else the paint. So before I even show you anything else, that you can already see that that is more accurate than this. Okay, see that? That's kind of rough, and this is quite accurate. Okay, now let's take a look around, and now look at this beautifully smooth silhouette of that ear, right? That's sort of a stencil that came through. That's just shows, and this is being done on a per pixel basis. So if I look at the wireframe here, right, and you can see that these are all being done in between polygons, all right? So that is a really good feature. So other than just stenciling out a shape like this, you might think to yourself, well, it's not really that important. I've been getting along fine without it before. Why is this so important? Why are you making such a big deal? I'm going to show you. So one of our users sent us this model, And this model was at first was a source of great distress, but then turned out to be the motivation for implementing this new feature. Now I'm going to show you. This is like it's a throne, it's a chair that was made in Google SketchUp, I believe. And Google SketchUp, if you don't know, has this kind of a CAD-like workflow. And so in any case, you can see first off, there's a lot of thin triangles, long, thin triangles, or really big ones, right? And so this is going to present a huge problem for our per vertex logic, as we showed before. So let me show you again. So the way it was before, per vertex, you want to paint on this. So you go here, and wow, look, all this stuff is faded, right? And see, and this is all, and let's do this whole thing again. And wow, like this is just not really good at all. Like number one, we have these big faded areas. Number two, these really thin triangles are presenting a problem, and it's just, you can't really work with it like this. What you could do is say, well, I'm not really concerned about, I'm just going to paint the same stuff on the front and back, so you can just use no hidden surface removal and paint through it and just get that. But that is not good in many circumstances. So this whole problem again, how do we solve this hidden surface removal? The answer is per pixel hidden surface removal. So let me show you now. We're going to use a precision of 100%. The precision is important for this because we're using these depth values, and there's a certain amount of error associated with them, and there's no one situation works. The one number works best for all situations in this precision. So we have to present this as an option for you. So anyway, 100% is the most precise. All right. Well, let's first off to show 50-50. There's 50%, and show you how this works now. And we just paint here, and look at that. Now, if we rotate a bit, we see this whole area got silhouetted out, all that hidden area, and all the stuff we wanted to paint, right, was filled with paint. So for this is exactly what we want. We don't have to worry about the vertices at all. We don't care about the shape of the polygons. It just works the same in this situation as it does for the other one where we had all these uniform sort of quads and polygons that were all relatively the same shape, right? So in this case, that works great. It's beautiful. And so I'm going to show you now the difference for the precision, why this precision value is important. So let us just make this the most precise it can be, right? As far as those detecting that change in depth, right? If we do this and paint here, we notice these edges, because there's a little change in depth between here and here, these edges get picked up and they don't get painted. And there might be situations where you want this, where you like you just those little nooks and crannies, you just want them to keep them the same color, whatever. It's just there's cases where you will want to have more precise, especially when you have really thin polygons close together. I'll show you another example later on that. But in any case, now let's say 50% precision and do the same thing, right? So it's being less picky, right? And all those cracks got filled in, minus just a little kind of specks here, just at these really sharp edges, right? All right, now let's make it the least precise. We know that this model, we don't have a lot of internal stuff like geometry that we're not worried about accidentally painting on. Everything's kind of, just, well separated from each other. We're not too worried about that depth precision. So then we put it at 0% precision, and we paint there, and voila. And we have that edge there, and the stuff behind didn't get painted on, the stuff in front did. Let's show you a few more cases here. And again, I'm going to point out, the purpose of this feature isn't for making sharp stencil patterns like this, right? The purpose of it is so you don't accidentally paint on stuff that's hidden or it's overlapped and it's behind. When you can't see it, you're painting, and then like half an hour later you realize, hey, you just destroyed the texture on another part of the model because it was obscured. That's the main purpose of this of the hidden surface removal features. It's just the But the thing is, in these cases where we have a sharp edge, we really wanted to make it as smooth and graceful as possible. So when you look at this here, for example, now let's take a rotate around. We notice that we made a lot of effort to make this, you know, a relatively smooth transition, right? And so, yeah. Anyway, that's that. So, again, you might say, okay, it's not all that impressive. Sure, that's kind of nifty, but here, this whole category of models that look like this, right? Previously, you couldn't paint them in realityPaint or other 3D painting applications which use poly painting techniques because this model just won't subdivide well. So if your painting application requires you to subdivide the model into millions of little tiny polygons and then paint it, it's not going to work really well when you have these really huge triangles here and these really thin ones, because I'm going to show you I'm going to do a subdivision on this right now. Select all and utility tools, subdivide object, 100,000 polygons, and let's just take a look at what we get. Now if you look at this model here, you can see you got this area here where there's tons of little itty bitty polygons, and here where they're actually quite large, right? And so, and even here, even though they're small and thin. They're like slivers, and they're just not really going to paint well in a poly painting situation. And these ones here, we're going to have very poor resolution, and here they'll be higher resolution, but it'll be kind of slivery. It'll just not look good at all. And so, this type of model, its subdivision is not a viable option for this type of model. And previously, as we discussed, that this sort of per vertex hidden surface removal wasn't a viable option as well. But now that we have this per pixel hidden surface removal, these types of models can now be painted in realityPaint as easily as any other models. These long, thin triangles are no longer an issue. There was actually a little tiny bug in the software as well, which made those sort of similar but unrelated issue with that made those really long, thin triangles not work very well. We fixed that, so now models like this will paint really well, and you open up a whole new category of painting possibilities with realityPaint Pro. And so, yes, I'm just going to show you one more little example just before we go, just to really illustrate that this precision value here, because this will no doubt sometimes not be obvious to people. So we have overlapping planes. So I've took the liberty of making two thin planes that are really, really close to each other. If you look at them from the left here, you can see that one is just slightly in front of the other one. So here we go. So if I paintbrush and I have precision and 100%, all right. Now if I paint over here, and now I take a look at the image maps that I just painted on. Here's the blue one, all right, and here's the green one. You notice how that area behind got completely stenciled out, right? And so that's great. So now I'm going to do the same thing, but with a precision of 0%. Right? 0% doesn't mean zero precision. It just means the minimum amount of precision that we've utilized for the algorithm. See, now you notice the green one got completely painted. So it's like it didn't care that the blue was in front of it because it's less precise, right? And and you might find that when these are really close together, you might get some situations where you might kind of speckle a bit. You might find some little dots because it's kind of fighting for, it's called Z fighting. It's where the depths are almost the same, and the way the algorithm works is that sometimes they pass, sometimes they don't. So if you see that kind of Z fighting over thin things, then you know what it is. But generally, if you have a situation like this, you don't really want to rely on that. What you want to do is you want to create a display group and hide the outer, the upper surface and paint on the lower one, or vice versa. Another case is when one of these heads that I showed you is that sometimes there's they make these little thin polygon layers over top of the eyes or over top of the eyebrows, and the point of those are for transparency maps, and they're really, really, really close together. And those ones in particular you're going to want to hide them away and paint on them separately. Or if you're just painting on that layer, you hide what's behind it, because they're so close together. You don't really want to rely on this hidden surface removal for that. So other than that, right? Other than that special case where you get these really thin overlapping planes, it's really not that big of a deal. You just maybe keep this at 50% unless you notice it's a little less precise and it's a really large object with a lot of depth, right? And you're getting some spillage. You might want to make it more precise, or likewise, as we saw with the throne, with those little cracks and crevices that weren't getting painted, you decrease the precision to make sure they all get filled in. So that's the only thing you have to watch out for. It would be nice not to have this and to have it smart enough to do everything, but life isn't like that. Sometimes you need to have an option. We try to keep the options as minimal as possible, but sometimes you just need to give the user a setting. And so that's what we did here. Now, so that is pretty much, let me show you. Oh, and there's been one more thing. We improved the auto UV mapping in the Paint Setup Wizard. This model in particular, this chair here, we noticed that, and is that when we auto UV map this, sometimes the polygons would get too close together from one section to another, and you get a little bit of spillage from one to the next. And if I'm not mistaken, I think this one was auto UV mapped. Let's take a look at the resolution visualizer. I think this one was auto UV mapped before he made the fix, so let's hope that it is, and let me show you what the result is now. So this is the way it worked before. So it was a kind of I guess there's a bug, certain objects it would show up and certain ones it didn't. There we go, beautiful. See that little black speck that just showed up? That's because when this section on here, let's go resolution visualizer, this sort of section here is on the UV map is really close to another section which we just painted black, right? And it's too close, and it didn't leave enough gap, right? And so therefore you can kind of see just a little bit of the paint showing up here. So what we did is we fixed it such that now in all situations, hopefully that is, there will always be enough gap there, except for maybe some rare circumstance when it's a really weird geometry. But we found the source of the problem. We found out why that gap wasn't large enough in some cases. We fixed that up. So now I'm going to show you, let's go Control A, select all, utility tools, paint setup wizard, yada yada yada, and let's just do it again. And there's actually another issue with this chair. I'm going to have another video that's going to just show you this chair because several issues came up, and I think that it would there's a few good tricks that that you can do to improve models like this and how you can paint on them. But anyway, let's not worry about that for now. Just know that there's another video coming up. So I'm going to paint this sort of section again, and you notice that little black speck didn't show up. This is a little different. That's just from either the Z fighting or one of those really thin triangles. It's just not painting right. You can always fix that just by saturating the whole thing with none. Let me show you. Yeah, these really, really thin triangles are very problematic for a lot of applications. And with this change that we just made here, we've eliminated 90% of the problems associated with it. But every little bit you might get, it might not quite paint properly. So you can either saturate the whole thing with color. First off, this black is making it hard to see everything, so let's just say red. All right. So you can either just say none, saturate the whole thing with roughly the color you want, right? And then go back to per pixel, and then do all of your detail. And if you get some little tiny speck that doesn't show up, that doesn't paint properly, you won't notice. But even more precisely, to fix those problems, in this case, use the bleed UV seam brush, because you're getting these little seam on a really thin slice, and it's just not being able to paint it properly, but this fixes it up as well. Anyway, that's all the subject of another video. So now, as you can see, with these, this one change we made, adding this one feature opened up a whole new category of 3D models that you can now paint with ease in realityPaint. Well, before you might have tried to paint a model like this and found out, it's just not working right, you just can't use it. Now you can. And so we're going to really sort of, this is just the start, because now that we have this feature, and it's working really well right now, but we really want to push it, make sure that all things, you know, involved with this sort of, these issues are really well thought out. And another issue is that we are considering, right, this per vertex per polygon for painting, right? If this works out really well, right, and we want your feedback for this, we would like to get rid of these, because sometimes when it comes to developing software, less features are more, right? It's better. Instead of having all these things, if there's no real purpose to having these anymore, we'd rather remove them and make everything a lot smoother and simpler. So when you're using this feature, really keep in mind, am I using these for painting at all? Right? Currently, they're still going to be used for selection tools, and we're going to look into that as well and rethink them. But in any case, please, we'd like to know your opinion on this. So we can either post on the forum or send us an email if you feel strongly either way. We're considering removing these if we can do everything with this, with the per pixel. So please just keep that back in your mind. We're not just going to take it away without any consultation. But if it turns out they're just redundant and not used anymore, we'd rather simplify things. So keep that in mind. And please, download the latest update. Here, help check for updates. Make sure you get this latest update. And sometimes when you do this, there's an error downloading the software and it says, please try again. Try it a few times. It's just a server issue. I'm not quite entirely sure how to solve it, but every once in a while, it'll be an error with the download, and you can just check it again, and it will work the next time or the time after that. So be patient, especially if there's a lot of people downloading it. Yes, I hope you've enjoyed this video. I hope you enjoyed this new feature. We're really excited what this means. This is, again, it's such a simple thing, but it's opened up a whole new world of possibilities, whole different sort of applications for the software, which were previously just, not very efficient. So, and performance. There's some good reasons that for high resolution models that this could be much faster. There's a whole lot of reasons why we're really emphasizing this. So we really encourage you to get your hands dirty, use this feature, right, and understand this precision, and ask questions. You can either email us personally or post on the forum. We really want to make sure that this software does what it's supposed to do well. Okay, I really want to emphasize this. We're really focused on taking the feature, what it does, that is 3D texture painting, and doing it as best as it can, having the software work as best as it can, and really working out these fine details. We're really dedicated to that, so your input is extremely valuable. We never would have implemented this feature if one user didn't send me this model and say, can you help me out with this, right? Because he sent it to me, I checked it out, and I'm like, okay, the easy answer is it's a bad model. But then I was like, well, maybe not. Let's take a look, and wow, and this is the result. So your input is extremely valuable. Anyway, I'm rambling on. I hope you've enjoyed this video. I hope you enjoyed this new feature. Please give us your feedback, and if you find any issues with it, if it's not working right in some situations, let us know, right, either email or the forums. We're very interested in your feedback. And so stay tuned, more videos to come. I'm going to have another video just featuring this object as well, because there's some other issues with objects like this that you should be aware of. And so we're going to use that as a case study. So yeah, thank you for watching. See you next time.